The title of these notes are Some Useful Theorems. Some useful theorems. They're all useful. Don't worry about it. So we're going to start off with a theorem. I'm going to do it in green because I want to. And this theorem states every polynomial with complex coefficients with positive degree n has exactly n roots. So let me write that down. Every polynomial with complex coefficients, and positive degree n has exactly n roots. What does this mean? What does it mean? If you have a degree 2 polynomial, then your degree 2 polynomial should have 2 roots. Exactly 2 roots. They could be double, they could be not double, they could be imaginary, they could be real, doesn't matter. It will have exactly 2. If you have a degree 3 polynomial, you'll have 3 roots. If you have a degree 4 polynomial, you'll have 4 roots. That's what it means. So, yeah, that's it for that. And then we can do another theorem. Just going to get them all out of the way. Conjugate root theorem. The next theorem, the conjugate root theorem, says if a polynomial with real coefficients, with real coefficients has a plus bi as a root, meaning when you plug it in you get 0, where a and b are real, they're real numbers, and then b is not 0. Then a minus bi, which is the conjugate, if this complex number is a plus bi, the conjugate, a minus bi, is also a root. This means if you have an imaginary number as a root, then the complex conjugate of it is also a root. So, for instance, if you know that 1 plus 2i is a root, then you also know 1 minus 2i, which is the conjugate, is a root. If 4i is a root, then you know that minus or negative 4i is a root. Okay, so if you have an imaginary root, its conjugate is also a root. That's all it's saying. That's what the theorem is. If you knew that a negative 4i was a root, then you also know that positive 4i is a root. So you can go either way. Example. So the instructions for this are find a cubic equation, so it has to have an equal sign, cubic equation with integral coefficients. Find a cubic equation with integral coefficients that has the given roots. And those roots will be 3 and I times the square root of 2. Just like before, if we're given roots, we can also find factors just by going x minus the root. So we have x minus 3 is a factor, and x minus I root 2 is a factor. From the theorem that we just stated, if we know that an imaginary number is a root, its conjugate is a root. So the conjugate of I root 2 is negative I root 2. So we can say this means that negative I root 2 is a root. Just from the theorem. Now we have 3 roots, which means we can make a third degree polynomial, which is what we want. A cubic, yeah. So we can start out by going x minus our root. So we'll do x minus 3 and then multiply it. Remember, if we have all the factors, we can multiply it together to get the polynomial, just like if we had the factors of 8, we can multiply it together to get 8. So x minus 3 times x minus I root 2 times x minus negative I root 2 equals 0. And then we just solve from there. So one thing I want to point out actually is this part came from the theorem. So from theorem. So back to this, we can just start solving these. Just start multiplying them out. I'm going to do these multiplied by each other first, so I'm just going to rewrite x minus I root 2 times x plus I root 2 equals 0. And then I'm going to multiply these first because the i's I think will go away. So x squared plus xi root 2 minus xi root 2 minus I squared times 2 equals 0, because root 2 times root 2 is 2. I squared is negative 1, so that leaves me with all of this, x minus 3. So I just multiplied these out, copying everything else down. And I'll have x squared. That goes away, and this becomes plus 2. And now I keep multiplying. X times x squared is x cubed plus 2x minus 3x squared minus 6 equals 0. And then combine like terms. Can I combine like terms? No. But I can rewrite in descending order just so it looks nice. And that's all I gotta do. It says find a cubic equation with integral coefficients that has the given roots. And we found a cubic equation. And we know that these are the roots because we multiplied it out that way. Very easy. A note that I want you to write down. Note. If I had fractions, all I would have to do is fraction bust. If I had fractions, then fraction bust. And that's it. That's all for that. Pretty simple. If they ask you to make an equation having certain roots, you always do x minus that root, multiply it together. So that's what we did here. And we used the theorem to get that third root. We needed 3 roots to get a cubic polynomial. Another thing I want you guys to do is to label this example, whoops, not 10, 11. Example 11. So this would be my answer. Alright? My light went out on my phone again because it's overheating, so deal with it. You got to deal with it.
It's all about you, girl. If you don't know, then you have got to deal with it.
I bet you don't know that song. The next example is really easy. I'm just showing you because you have stuff like this to do in your book. So let's do this. Find the remaining root. These are the instructions. Find the remaining root of the given equation. This is also just using the theorem. If we know the theorem, we know what it means, we know what it can do, we use it, we're done. That's it. And then also it says check your answer. Check your answer. And what that means is plug it back in, make sure that it is actually a root, meaning that it gives you 0. So the given equation will be x to the 4th minus 3x cubed plus 4x squared minus 6x plus 4 equals 0. And the given roots are 1, 2, I root 2. 1, 2, I root 2. That's not funny. That's just weird. It's not funny.
The blood. I'm funny. I'm funny.
I know, it's so funny. Yeah, it's not funny. Not funny.
The blood. I'm funny.
So we have an imaginary root, so we can use our theorem that says if we have an imaginary root, its conjugate is a root. The conjugate of I root 2 is negative I root 2. So since I root 2 is a root by the theorem, it's a conjugate root theorem, negative I root 2 is a root. So find the remaining root. Found it. Bam.
Check, please.
Check your answer. We gotta check your answer. So here's the check. To check, all we have to do is plug in our root to our equation and see if we get 0. See if this is true. Equals to 0. Let's do this. Negative I root 2 to the 4th minus 3 times negative I root 2 cubed plus 4 times negative I root 2 squared minus 6 times negative I root 2 plus 4 equals 0. Let's see. Let's see if it's 0. All right. We'll see.